Welcome to Chapter 3 on controlling your MTH with a PC. This diagram shows the whole system in one schematic. You have the PC, you have the CTI network, you have a stamp, you have an interface card, you have the TIU, and you have the remote. Now the way the system works is the stamp receives data from the CTI network telling it which engine and command it wants, and it sends it through the interface to the TIU. Likewise, the remote could go through that same interface and talk to the TIU. Either one of them can talk to the TIU, they just can't talk exactly at the same time. So I'm going to focus on the CTI network. The CTI network is what I had in place before I started this project. Although I show 3 or 4 cards on here, I actually have about 10. They run switch tracks, accessories, and so forth. But you will notice here that there's a splitter after the 3rd card. And that takes the signal from the PC that's going to go to the CTI Yardmaster, and it splits that signal and sends it to the stamp. The Yardmaster normally holds 16 relays. And when you send a command to it, it sends 2 bytes to that card. 2 bytes to that card. 1 byte with 8 bits setting 8 relays, and the other byte commanding 8 more relays. But there are no relays on this card. I'm just wanting the PC to think there is, so I can send 2 bytes out on the network. And the first byte says what engine I want, and the second byte says what command I want. And the PC doesn't know that I'm stealing that command and sending it to the stamp. Now, like I said, the stamp is connected to this interface unit, and it will deliver the signal to the interface unit and onto the TIU. The remote is also connected to this interface unit, and it would likewise will send data and interface to the TIU. So for the moment, I want to show you this Yardmaster card. This is a typical looking card. The only thing you'll notice is that there's holes in it with no components other than the microprocessor chip. But normally there would be relays there, or sophisticated solid state relays, but there are none. Again, I'm just using the communications of that chip to trick the PC into thinking that there's a 16-bit message it needs to send, which I steal and send on to the stamp. So let's talk about the stamp. Okay? This is what the stamp looks like. It's the most expensive part of the whole process. It's about $79. I bought this one because it had the most EEPROM, 16,000 bytes of EEPROM available. And like I said, it's a BS2PX stamp. Now that stamp plugs into this $19 Parallax Super Carrier board. You plug this into the Super Carrier board, and the board already contains all the hardware to power it, plug it in, RS-232 port for loading the stamp, loading the software, changing the software, and then out to the right you see a small area there where it allows you to load, or not load, but actually put components on. Now I'm going to show you on this schematic what I've actually loaded onto that Parallax stamp card. There's basically, it's not very much. Pin 0, 1, and 2, there's 15 pins on the stamp that can be used for input and output. I use pin 0, pin 1, and pin 2 to communicate with the stamp and with CTI and the handheld. So pin 0 pin 0 is the output of data to the TIU. Pin 1 is the input of data from the remote for loading. Pin 2 is the input from CTI. After that, the remaining pins are used to light LEDs, monitor switches, and pins 8 through 15 are used to run that LED segmented indicator. And all these, the two LEDs and the LC LED indicator, and all the switches and buttons are used to push it into the load mode and make it easy for you to keep track of where you're loading stuff. I use two standard telephone jacks on this card. One for CTIN, which uses a standard telephone jack, and then a standard telephone jack to the interface card. If you look at that interface card, I'm actually sending the 5 volts from the stamp over to the interface card to power its components. The black line's the signal going out, the red line's the signal coming back to the stamp, green line is ground, and the yellow line is the 5 volts. All right, just as a reminder where the interface card is, again, it's between the stamp and the TIU. Its main function is to provide a way to connect the remote to the stamp, and then the stamp and the remote to the TIU at the same time. Like I mentioned earlier, either one can be used, but not simultaneously. If you try to send one signal on top of the other, the TIU will get bad data, and you'll probably get a TIU error message. All right. The deal about the interface card is was very cheap to build. I think the total parts of it was about $3 worth of electronics. The difficult part was soldering this tiny little AND gate onto a tiny little circuit board that had pins on it so I could stick it into the card. You can see by the picture here it's a pretty sparse deal. It's got 3 telephone jacks. The white one is a standard telephone jack, and the 2 smaller gray ones on the bottom and on the right, those are the small telephone jacks that are used on the TIU and the remote. They're the ones that are normally found on the receiver of your telephone on the old telephone systems. So the LED lights when you are in the connected mode, meaning running tethered with either the stamp or the remote. And when you throw a switch, that light goes out to tell you you're in the wireless mode. So here's a schematic of the whole of the interface card. It looks busy, but it's really not. It's a matter of keeping track of the wires. But basically, you sum the 2 signals, one from the remote, one from the stamp, and that sends it off to the TIU. However, like I say, you don't really send both at the same time. And you'll see the large switch shown down there on the lower right, which disconnects all the wires from the remote and the TIU, the remote and the stamp from the TIU, which then puts it into the wireless mode, and you can run your handheld with wireless. So now I'm going to do is I'm going to show you a video of the whole thing in action, and I hope you enjoy it. Okay, this is a short video of the control system up and running. You can see here that the 2 green LED lights are on the stamp board. Right now this is in the run mode because there's green lights on, and the LCD, although it looks like it, it's actually the segmented LED is not lit. Now I can force this device into the load mode by holding down this button right here that I've mounted, hitting the reset button, releasing, red light comes on, and the LED lights. It's telling me now that I'm ready to select the engine. So my first engine I would want to enter, let's say I've already got 1 and 2 in, I need to put in 3. I now select 1, 2, and 3. Now I'm set up to load engine 3. I take this toggle switch up here, I throw it over, and now I can take my handheld into my hand, and I go through that sequence I talked about in the signals chapter, where I start with the start command. I'll wait till the green light comes on, then it'll tell me it's time to hit the next button, and so on and so forth, and it just kind of walks me right on through. When I'm all done loading, I throw the switch back to the normal position, and I just hit the reset button, and now I'm back in the run mode and ready to run. So that's how it works. Now over here, this is the interface, again, for the stamp and the handheld together. They're parallel together. The red LED light that you see on is quite bright, indicates that I am in this tethered mode and running with a PC or the handheld. If at any time I want to switch over and go wireless, all I have to do is take this switch here, throw it, the LED light goes off, and it tells me I'm now in the wireless mode and I can run the handheld wirelessly. I don't need to disconnect the cable from it if I don't want to, and I can run wireless. So there you have it. That's the whole system. Obviously, the details that you're missing are how do you write the software for the processor chip, and of course, if you own CTI, how do you write the software or the logic, the commands and the syntax to send the data off. Well, if you buy a CTI system, it's got a really great handbook, and it's a real simple system to learn how to program. And the reason I picked the Parallax, by the way, is because it was simple. I know how to program in BASIC. It's a more expensive way to go. There's those of you out here that may be familiar with Adreno chips. That may be a less expensive way to go. It requires you to be able to program in C++. If you actually know enough about electronics to make your own little board and power up a PIC, there's PICs out there you can buy for $1.50 that have all the same processing power, and but you have to learn to program in either machine language or again C++ and buy the assembly software to do all that. I didn't want to learn a new language. I spent a long time trying to sort this thing out, and the Stamp offered me a really easy. They had a great little training book I bought, and I did their little projects for about 2 weeks, and I got so I actually could figure out what the heck I was doing. So there you have it. If any of these charts don't show up and you'd like copies of them so you can look at them more in detail, I noticed they didn't show up really great on the video. Just send me an email and I'll send you a package maybe that has all these charts on them. So again, I'm hoping you all, some of you will get excited about it and do it. It's been a great project for me. And don't hesitate to email me or at least comment on the forum or ask your questions through the forum. So that's it for now, and I don't plan on making any more videos unless I get enough questions that warrants it. Thank you.